Hey, good morning, everybody. Math by the Moon back with another video. Had to dig pretty deep down for this shirt in the dresser this morning, but we're representing Williamsport good and strong. I want to get into sketching graphs of polynomials with you with degree, based on their degree and their zeros, and it's all based on end behavior as well. So I know that I did a video with end behavior earlier on about evens and odds. So that's going to be coming into play as well. The questions in Edgenuity look something like this. They have a function f of x equals, and it's in factored form already. So the first thing we can do once it's in factored form is we can determine the total degree of the function. So the way that would work is if we were to multiply this out, we'd get a square times a cube. And it would be a big deal because you'd have to do the x plus 4 times x plus 4 and the x minus 3 times x minus 3 times x minus 3. But the bottom line is it's going to end up a fifth degree polynomial because you're multiplying a square and a cube. So we know that it's going to have degree 5, which means it's odd. And an odd polynomial we know goes up on the right and down on the left. It does not have a negative coefficient in the front, so that doesn't flip it the other way. So when I look at my graph, I know it's going to kind of do one of these, right, like that. So that's going to be the overall idea. It's going to have two zeros. It's going to have two zeros. It's going to have a 0 at, for this one, it's going to have a 0 at -4. And it's going to have a 0 at 3. Okay, now, since it's degree 5, I know that I can place these zeros and I can sort of sketch my end behavior on each side of the picture, meaning past the 0 that's the furthest to the right, I'm going up. Past the 0 that's the furthest to the left, it should be going down. And that's how we can kind of get the idea of where it's going to turn and how it's going to undulate through this graph. So let's lay the zeros down, a -4, and a 3. And like I said before, the furthest 0 on the left is the -4, and I know that it's going to be down over here. My end behavior is going to be going eventually down. On the right, I know it's going to eventually go up because of the end behavior. So I'm going to put that over here after the 0. So now we need to look at multiplicity. And the zeros, -4 and 3, have a power, and that power tells us what it's going to do at the 0. If it's an even power, its multiplicity is even, it's going to bounce off, just like a parabola, like an x squared. It's a u. So if it's coming from the top down, it's going to bounce off. If it's coming from the bottom up, it's always going to bounce off. It will not cut through the 0. So here, I'm coming from below it, so I'm going to bounce off. Okay? And then I don't hit the x-axis at all until I get over here, which is at my 3. And the 3 has a multiplicity of 3. It's a cubic multiplicity. So I know that I'm going to, since I don't turn back around and hit this at all, I know I'm going to turn around, and as I come through this 0 right here, I'm going to pass through. And since it's a cubic, I'm even going to pass through almost like a cubic. And then you can see how I can end up and connect my end behavior. So if it's an odd multiplicity of the factor, like a 3 or a 5 or a 7, you're going to pass through the 0. And if it's an odd that's higher than a degree of 1, anything with a degree of 1 almost looks like it goes straight through. And I'll show you one of these right here. But when you have an even multiplicity, it's going to bounce off from whichever side of the x-axis that it is coming from. So getting the idea of the total degree, the zeros, and knowing on each side where it's going to go, right, after the 0, tells you a little bit about this graph. So the second example we have is going to have 3 zeros this time. I'm going to have So first of all, the degree, let's start with the degree. We got a fifth degree because we have a cubic, a square, but then we have this one right here, which is going to add another to the degree. So it's really going to be degree 6. So it's an even. So I know that it's going to go up on both sides. And yes, it might wiggle, 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 yeah. It might wiggle, 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 yeah. But both sides go up. Now the zeros, this one right here, this factor, x could equal 0, x could equal 5, and x could equal -4. So I'm going to lay these on my x-axis. Okay, and I'm going to put my end behavior up on the left and up on the right after the zeros. Okay, now I'm coming down to this one right here, which is at -4. And -4 has a cubic multiplicity. Whoops. -4 has a cubic multiplicity. So that means I'm going to pass through it. Okay. Now I'm going to have to turn back around in my graph and I'm going to have to come through the 0, and I'm either going to bounce off the 0 or I'm going to cut through it. Well, since this x has a power of 1, I'm going to cut through it because 1's odd. So I'm going to turn back around and I'm going to cut through it almost in a straight line. Okay. Now the last 0, and you know what, it's almost obvious because I only have one more 0. And so I can't go below this point anyway. I'm going to only be able to touch it and bounce off so that I can connect to my end behavior. But let's just prove it. So it's a 5, right, is the 0 with a multiplicity of 2. So it's even. Yes, it's going to bounce off. So I come over, bounce off, and back up. And that would be your sketch of this graph. I know in Edgenuity, they make you find values of in between here to plug into the function. But if you understand end behavior and you understand multiplicity, I think that that's not necessarily a waste of time, but it's not needed really to be able to sketch the graph of the curve. The last one I have, needs factored itself. Okay, so if we look at this function, I know that I have, let's slide down here. I know that I have an x cubed that I can factor out, and I'm calling it h of x. So if I factor out an x cubed, I'd have an x squared minus 9, and that's a difference of squares. So I can use x plus 3 and x minus 3. So now I have 3 zeros again. I have 0 for this function, for x cubed. I have -3 and I have +3. With the overall degree is 5, so we know it's an odd. We know it's an odd curve, so we know the end behavior is going to go down on the left and up on the right. So let's lay the zeros down and get our end behavior where it needs to be. I'm going to start with the -3, the 0, and the 3. And like I said, I know that it's going to go up over here and it's going to go down over here because that's what the odd ones do. On the left, it goes down, and on the right, it goes up. So my first 0 that I'm approaching is -3 because I'm approaching this one right here, -3. And I have only a power of 1 for -3. I only have a power of 1 for the +3 also. So both of the 3 and the -3 I'm going to pass through, almost like a straight line. Now I have to turn back around and I have to come through the 0. And with 0, 0 is x cubed. So I know I'm going to kind of wiggle through the 0 almost like a cubic. And then I got to turn back around to come back up through and connect here. And since it's a power of 1, I know I'm basically going to go straight through and connect to my end behavior. So figure out the overall degree. That's going to tell you how it operates. Figure out the zeros. And then based on this multiplicity, if it's an even multiplicity, it's going to bounce off. If it's an odd multiplicity, it's going to go through. And sketch your graph. Do the best you can. I'd be glad to hop on a Zoom and help you out. If you need more in-depth discussion about some of the examples, hit me up. All right, later.